All right, here we go. So, what we're going to do here, okay, you're going to need a pencil or some other writing implement, something you can erase. Does anyone need a pencil? I only have 2 left. Anyone need a pencil? You're going to want a pencil, okay? Yes, sharpen in the back corner there. You need a paper. Oh, you have a pencil. Sorry about that. Anyone else need a pencil? You will need a pencil. Anyone else need a pencil? Anyone need a pencil? You're going to need a pencil out. Okay, make sure you have a pencil out. Please get out a pencil. Okay, Mr. Witt also has a pencil. Let's see here. The reason why we need a pencil is because we're going to be erasing. So you're going to need to be able to get rid of stuff, right? And you can't really erase pen very nicely. And even then, they don't really erase that well. I mean, they do, but they don't. Okay. Oh, yeah, I thought you were raising your hand to go somewhere. All right. You're like pranking Mr. Witt. So, okay. Please forgive me also, folks. There's like, the copy machine was acting funky on me when I was copying these for us. Okay, but here we go. So, on the graph below, all right, Chloe, go back to your seat, please. Lauren, back to your seat, please. We're doing it now. I'm just going to take care of it, just so that way I don't have to worry about it anymore. Please go back to your seat, girls. All right? You can go back later if we have time, but right now I want you back to your seats. All right? Nothing personal. I just don't want to have to keep asking. What's that? I'm sorry to hear that. He'll be back. All right, so here we go. Okay? All right. Dragging the feet. On the graph below, graph each of the equations lightly with a pencil, label each line. We're going back to like Algebra 1A here, graphing equations of lines, okay? So, what form is this line in? Y equals mx plus b, or also known as slope-intercept form. What is the intercept of this line? The 8. B is the 8 here. So you're going to go all the way up to 8 on your coordinate plane here and put a point. Right? And then from this point, we're going to go, what's our slope of this line? Up to right 1, right? As a fraction over 2 over 1, right? So up to right 1, right? I run out of space, so I'll also go down to left 1, down to left 1. And yes, we're going to graph the whole doggone thing here. So do the whole line if you can. Okay? And then we're going to connect the dots. Do it lightly, please. Lightly connect the dots. In your pencil. I'll tell you when we're going to use the marker here. Do you need another paper? Yeah. Okay. Yeah. Just drawing a line with our pencil for right now. Just pencil. Nah, because you're going to have to erase. So that's okay. Thank you for telling me now, because otherwise it would have been even more catch up. Okay, and we'll label this line M. All right, so I graphed it and labeled it line M. There's my line. I can put arrows on it if you like. Okay. All right, now we'll go ahead and do line N. Now line N is f of x equals 2. Okay, so how do you graph f of x equals 2? What kind of line is that going to be, Jackson? Not a vertical line. So horizontal. So it's going to be this way, right? Okay, across it, and we're going to go through 2. Right? This is like y equals 2, right? If you want to think about y equals 2, right? So it's just like through the y coordinate of 2. So it's going to be this horizontal line right here. Okay? Now, normally, right, we treat these things as 2 separate functions. We'll talk about what's going to happen with the piecewise function, though, here. Okay? All right, and then line P, all right, what is its y-intercept? That's a 7, yeah, it's a 7. 7. And then what's the slope? Negative 1, so we're going to go down 1, right 1, down 1, right 1, and then up 1, left 1 as well. then oops, I'm not drawing. I forgot to draw lightly. I'm starting to make it really dark. I mean, if you draw it too dark, that's okay. I mean, you should still erase okay, because we're going to use the markers, and the markers will really stand out. Okay. Okay. Oof. Okay, so this actually says we're going to use 2 different colored markers. We're not going to do that. We're not going to do that. Okay, we're going to do instead, I'll just use my pencil again. So for number 2, for step 2 here, we're going to use our pencil again. So what I've got right now, okay, and this is line P right here. What I've got right now is all 3 lines together, okay? Now, you can think of these lines as 3 separate lines, right? They're 3 separate functions, all graphed simultaneously, or we could think of them all together as one graph. It's the graph of all 3 lines together, right? So you can think of these as individual line graphs, or you can think of this as one graph of 3 lines all together, right? Now what we're going to do is we're going to graph parts of each of these lines and create a new graph, okay? We're going to graph parts of each of these lines and create a new graph. So let me show you what I'm talking about. So, step 2 says use a colored pencil or highlighted to draw vertical lines at x equals -3 and x equals 5. I'm going to use my pencil and just do like a dotted line here. So at -3, let's draw a dotted line. So there's -3, so a dotted line, vertical dotted line there. Okay, like that. And at 5, also a vertical dotted line. Okay, vertical dotted line through -3 and 5.
All the way through.
Yep, all the way through. Whole way.
I thought you just
No,
said.
whole way, please. Okay. So far, so good? All right, now grab your markers. Okay, grab your markers. I'm going to use red so it stands out real good. There, you guys, whatever you got. Whatever you got, you got. Say again? We're going to we probably won't have any more quizzes. It'll be a test. There might be a quick check at some point next week, but the next thing will be a test. You don't have a marker? You want blue or black? Or green? Blue. Just make sure I get that one back, please. I use that for my notes. Okay. Next we're going to do step 3. Okay, it says use a dark marker to trace. Now, we're going to trace line M on the left side of the graph. So you see here, these vertical lines, it split up our graph into 3 sections. We have the left section over here. We have the middle section in between the 2 vertical lines. And then we have the right section over here to the right of the vertical lines. Okay? Who said that? Okay. So we have 3 graphs, right? You got that so far, 3 lines. So far, so good, right? Then we took these 2 vertical lines here, and we're breaking up our whole graph here into 3 sections. We have this left section, this middle section, this right section. Okay? What we're going to do then, the directions here say trace line M on the left side of the graph. So let's look over here. Here's the left section, right? Here's the left section. Okay? Where is line M here in this left section? Which piece is it? Is it this piece right here? Yes, down in quadrant 3. It's this piece right here. So trace line M, but only, if you want to watch me, I'm going to do it right here, okay? So here's line M, right? How do I know that? Because I labeled it up there, okay? So here's line M. I'm going to trace it on the left side of the graph. So watch this. Here's what I'm going to do, okay? So here's the left side of the graph. Left side, still on the left side. Still on the left side, still on the left side, still on the left side, still on the left side. Ooh, stop. There, I get to my border. Stop. Okay, so that's what you should trace, what I just traced right there. All the way to that border line, the dotted line right there, border line.
How do you know to stop at that point?
Because the directions say graph or trace line M on the left side of the graph. If I cross that border line, I won't be on the left. I'll be in the middle now. I'll be in the middle section. Okay. So far, so good? Any questions on that so far? This is important because you can't erase marker, right? So please make sure you get that right. Okay. All right. The next piece we're going to graph. We're going to graph line N in the middle of the graph. Okay, now let's see here. Is this line n right here? Is this line n? Nope. Is this line n right here? That's line P. This is line n right here. So we're going to graph line n, and again, in the middle of the graph. So start back at the border there, and we'll go across horizontally, and then stop at that next border line, right? Just the middle part, just the middle section there of line n. Okay? Finally, we're going to graph line P on the right section of the graph. So here's line P right here, and we're going to graph the part that starts on the right section. So this is the right section of line P, right? So we're going to go down. Just like that. Okay. So what you see in red, that is a piecewise function. Okay? Why do we call it piecewise? Because it is defined, it is made up of different pieces of other functions put together. Okay? You can see why I call this like a Frankenstein, right? We took a piece from line M, then we added a piece of line N, then we added a piece of line P, and it created this new function, a very funky looking function, right? A very atypical, different, weird, strange, unique kind of graph, right? That we're used to seeing. That's piecewise, okay? Because we have different pieces that make up this graph here. So let's think about how we would write this. If you go down to the very bottom of our equations, or of our paper here, I should say, okay, you'll see the three parts, the three pieces, right? So we've got the 2x plus 8, the 2, and then the negative x plus 7. Okay. And now we're going to talk about the domain, okay, of these different pieces. So for example, 2x plus 8, right? At what x value did we stop this 2x plus 8? What was the x value where we stopped this 2x plus 8? Negative 3, right? It stops right there at negative 3. And so this piece is true for x values to the left or less than negative 3. Okay? And then for the 2, which was line n, remember n was line 2. Line y equals 2 right here. There's line n. What x value did line n start? At negative 3. And what x value did line n stop? At 5, right? So between negative 3 and 5, that was the graph. And then finally, the negative x plus 7, that was line P right here, right? At what x value did line P start? At 5, right? So it's for x values that are greater than 5. There was line P. Okay. This is how you write a piecewise function. You say f of x equals, you put a big brace symbol there, and then you write however many functions it takes to define your piecewise function there, and then you tell the domain right here between what x values, does it occur and stuff. Okay? Questions on any of that? So, we can do this on the graphing calculator too. Okay? So let me show you how to do it on the graphing calculator. All right? Do you have your graphing calculators handy? If not, get them out. Okay? Oof. Okay? So let's see this on the graphing calculator now. Show you how to do it. All right, so to do this on the graphing calculator, what we're going to do, we're going to type these three functions into y1, y2, and y3. So 2x plus 8, 2, and then negative x plus 7. Okay, just like this. Okay? Now, if you graph right now, you're going to see what we had at the start, where everything was graphed all at once, and it was just a mess, right? That's not the piecewise function we want. So we have to tell the calculator to use these domains. Okay? We only want to graph the first function for x values less than negative 3. How do we do that? Well, go back to your y equals, put parentheses around your y1 there. So parentheses 2x plus 8. Okay. Everyone got their parentheses around the 2x plus 8 there? No? Okay.
Yes.
Yes? All right, 2x plus 8 in parentheses, then divide by, open another parentheses, and type in an x. Okay, what we're going to do is we are going to divide by the inequality that's here for the domain. We're going to divide by x less than negative 3. Okay, we know how to type in an x, but where's the less than symbol? Well, I'll show you where the less than symbol is. Okay, so we want to type in, again, this domain here. So we need to type in a less than. To get to less than, you're going to press second math, and that takes you to the test menu. And look, there are all your inequality symbols. Okay, we want less than, so go down to number 5. Okay, and see I have x less than. And I want to be less than what? According to my piecewise function, I want x less than negative 3. And then close the parenthesis. Now, let me show you how our graph changes. My line stopped. See? It didn't go beyond negative 3. Right? I said x less than negative 3, and when I graph the line, it stops at negative 3 now. It doesn't keep going. All right, we'll do the next thing here for 2. Let's put 2 in parentheses. It's not necessary to put this 2 in parentheses, but I'm going to do it anyway. 2 divided by, okay, now this one's tricky because you have 2 inequalities here. This is a bit trickier. Okay, so we'll type in the first one. So we're going to do negative 3, second math, less than x. Okay, so you see how I typed it in there? I'll type the first part of the inequality in there, negative 3 less than x. Okay, but it won't work if I put another less than and 5. So I can't type it in just like I see it here. I'll show you what we have to do instead. It's a little frustrating that they don't let us do that, but so it goes.
Really? Let me try.
It won't work. You can try. It won't work, though. Okay? So what we're going to have to do here, because the calculator doesn't like us having a compound inequality like that, we'll go second math and arrow over to logic, and we're going to put an and in there. So you see, there's my negative 3 less than x, and, again, that was second math, and then logic. I'm going to use the and there. Okay, whoops. And then we're going to type in the other inequality. So x math less than 5. I can remember all this? You don't necessarily need to. It's just helpful to see. Okay. This is just if you're curious here how to type this in your calculator. Okay, so again, there's the 2 divided by negative 3 less than x, then and from the logic menu, and then x less than 5. Okay, and then go ahead and do the last one if you're feeling confident here. I'll do the same thing. Okay, and then when you hit graph, 1, 2, 3. There they are. Look at that. Okay, same thing we got. Okay? Questions on any of that? So that's how you can use your graphing calculator to graph these things. If you flip your paper over, there's all the key presses. Wowie, wow, wow. That's a lot. Yeah, we don't have to worry about that, okay? I don't even know how helpful that really is, but there it is. Okay, it's not super helpful, but there it is. Okay. There's another piecewise. It's a different piecewise function. See, there's another funky. Look, you can get all sorts of crazy things on your piecewise functions now. I mean, this is like for those of you that maybe always wanted to like be able to draw on your graphs. This is how you can like really draw. Yeah.
So in the second math, there's an equal. So if you have an equation that's like
you won't. Yeah. So that's not. Unfortunately, that's you won't be able to use your calculator to solve an equation. Not that way. There is a solver on your graphing calculator. I'm not really sure how to use it myself, which I'm ashamed to admit. But there is a way, but it's you can't do it using that. Unfortunately.
If you're like really skilled enough. Wait, how do we go to logic?
Second math, and then arrow over to logic. Okay, I got one more paper here. We're going to do a little more practice of these piecewise functions. Oh no! You got it there. It's supposed to be, but I'll get it. Pass down, please. Thank you, sir. Bless you.
Thank you.
Nope, you can keep it. We're going to probably still use it, unless you don't want to use it. You can keep it though. Thank you, Lauren. For now. Nice shirt, Sky. Have you watched season 2 at all yet? Is it good? I heard the animation wasn't as good, but. Oh, okay. Okay. I've seen season 1, and yes, I really like it a lot. Yeah. I mean, back when I was in high school is when like Toonami first came on Cartoon Network, and they put like Dragon Ball Z and stuff like that on there, and so that's when I got into it then. And One Punch Man is kind of like a, not
successor?
a parody, a spiritual successor, or something like that. Yeah. So it's fun. And the animation is fantastic. So.
I'm trying to get my dad into Dragon Ball Z.
Nice. Good. All right, so let's try another one, right? Okay. I really like piecewise functions, but I know they can be tough, especially when you're first learning them at the start. But there's just so much you can do with them, and there's so many different little, I don't know. It's interesting, I guess, but I'm a math teacher, so of course I think it's interesting, right? Okay. So let's do this one. Now, these are saying graph it without a calculator. So let's really try to do this without a calculator here. All right, so first we'll graph this piece, 2x plus 3. Okay, so what will this graph look like? A what? It's going to be linear. It's a line. Yep. What is the y-intercept? 3. So we'll count up to 3. 1, 2, 3. Put a point. Okay, and then what is the slope of this line? Does matter, Kaylee? Okay. What's the slope? 2 and up 2 over 1. Right, up 1, 2, right 1. I'm going to graph the whole line here. Graph the whole line. Okay, I'm going to, again, lightly draw in pencil here. Okay, and connect those dots. Lightly draw in pencil and connect the dots.
So it's up to.
Yep, up 2 over 1 or down 2 left 1. Okay, can everyone see? Oh, Alex, question. If you don't want to do it, if you want to do that, that's fine. Yes.
Okay, good.
Yes. If you guys are comfortable with that, yes. If you feel like you can go ahead and do the domains, on your own, feel free. I'm going to do it more steps for everyone here. Okay. Next one. 3 minus x. Frank, question.
My calculator doesn't like it when I put in the numbers to make
The piecewise function? Okay, I'll come take a look at it. Actually, if you want to bring it up here real quick, if you don't mind, I'll take a look at it. All right, let's graph this one. What's the y-intercept of this one? No, you can stay up here. I got you. You forgot an x.
Oh.
Okay? So, what's the y-intercept again? Sorry? 3. You were good job though, Frank. You were very close. Yeah, so 3 again, but now our slope is going to tell us to go what way?
Down.
Down 1, right 1, right? Down 1, right 1. And again, up 1, left 1. Okay. Down 1, left 1 for this second line right here. This is 3 minus x. This is 2x plus 3. Question? You were graphing it with the graphing calculator? Oh, you have x negative 3. It should be 3 minus x there. So, and everything else looks good. Oh, you got to put I think you got to put divide by 0 there. Divide by 0. Divide by those. And that should work. Okay. So, now, got one more thing. What's our borderline here? What's our borderline going to be? Where are we switching? At what x value? We're switching at 0, right? So 2x plus 3 is our graph for x values that are less than 0, right? To the left of 0, we're going to be graphing 2x plus 3. To the right of 0, for x values greater than 0, we're going to graph 3 minus x. So at 0 is where we are switching from one to the other. So I'm going to draw or graph or draw in my vertical borderline there. Yes, sometimes I get my merge mixed up.
That's funny.
Yes. Merge mixed up. All right, so. Okay. So we're going to now graph this 2x plus 3, but we want to be to the left, right? That less than 0 means to the left of 0. All right, so there's our 2x plus 3. We're only going to color in or highlight the part that is to the left of 0. So for this 2x plus 3 line, only color the part that's to the left of 0. So that's this part right here. That's my 2x plus 3 line, and it's left of 0. Okay, so you see I go up to 0 and I stop. Do not continue, right? That's our borderline. Go up to 0 and stop.
So you go up to the intersection.
Yep, go up to the borderline here. In this case, yes, they're intersecting. They won't always intersect. But in this case, they do. Now, at 0, what kind of endpoint should I put? There's no equal to. So should my point be solid or hollow or open? If it's no equal to, it should be open, right? So I'm going to put an open circle at the end there. Because it doesn't have the equal to. Okay? Now, for x values greater than 0 and x values greater than 0, those are on the right or on the left? X values greater than 0 are on the right or on the left? The right. These are values greater than 0, right? All these x values are positive, right? And so we're going to graph 3 minus x to the right. So here's 3 minus x. This is the line, 3 minus x. We're going to graph to the right of 0. So right of 0, color it in there. Okay, just like that. Now, at 0, what kind of endpoint should I have? It's an equal to, so it should be solid or open. Solid, yeah. So we're actually going to fill in this circle here because they join up. Yep, it's a solid dot there. So they actually join up. We have a solid dot at that point. Okay. So this is a piecewise function. Another piecewise function. Okay. And we're going to answer these questions here too. All right. So f of 0, you can see here that the x, well actually, sorry, any questions on the graph right here? Any questions on the graph? If you want to, you can erase these pencil markings away if you want. If you want to erase away the pencil markings, so that way you just have the graph there. That's your choice. Okay, there's our piecewise function. Okay, so we're going to evaluate the function now. So f of 0. So you notice here that x is replaced by 0. So what is the value of our function at 0? It's 3. Okay, there's 2 ways to go about doing this. Ooh, this pen is D-E-D. D-E-A-D. It's 3. There's 2 ways to go about doing this. One way to do this is to look at your graph. Okay? X is equal to 0 right here, right? There's the 0 x value. And if I go to my graph, what's the matching y value for this x value of 0? It's 3. It's 3, right? 0, 1, 2, 3. So 3 is how we get that. The other way you can do it is by going to our piecewise function. But wait a minute. There's 2 different functions that I could plug 0 into. I could plug 0 into this x, or I could plug 0 into this x. But my piecewise function tells me which piece I can plug it into. My x value is 0. Which piece, the top piece or the bottom piece, should I plug it into? Look at your domains over here. Which piece is in charge of x values that equal 0? According to my domains here, which piece, the top or the bottom piece, is in charge of x values that are equal to 0? The bottom piece, right? It's got the equal 0 there. So we plug 0 in here. What's 3 minus 0? 3. Hey, there you go. Okay, let's try the next one, f of negative 3. Okay, one option is to look at your graph. Here's the x value of negative 3 right there. What's the matching y value for the x value of negative 3 on my graph? Well, that's where I'm pointing right now, but what's the matching y value on the graph, Jackson? 0 is where I'm pointing right now, but that's not on my graph. What's the matching y value on the graph here? You need to zoom in some for you. Yeah, -3. Very good. -3 is what we go to, -3. Okay? We can also, again, use the function. So look at the function up here. Which of my pieces should I use? If -3 is my x value, which piece is in charge of x values that are -3? The top or the bottom? The top, right? -3 is less than 0, so we have to use the top piece. So it's 2 times -3 plus 3. So we put in the top. Okay? This one we put in the bottom. 3 minus 0 there. Okay? 2 times -3 is -6 plus 3 is then -3. And so there's where you get your -3 there. All right, let's try 2. Let's do it backwards this time. We'll do the function first. 2 is my x value. Which piece of my piecewise function is in charge of x values that are equal to 2? The bottom, right? 2 is greater than or equal to 0, so it's the bottom piece, and we put the 2 in for the x. So it's going to be 3 minus 2, so again, back in the bottom there. Okay, what's 3 take away 2? 1. Look at your graph. 1, 2. There's the x value of 2, and look at the matching y value. It's 1. 2, 1. Okay, so we get 1 there too. All right. So the function and its graph both help us with these parts. Okay, the function and its graph can both help us solve. All right. Let's do one more here. Uno más. Okay. One more. No más.
How about tres más?
Trace mas? All right. You'll be here till 2:45. I got to be here till 2:45. So, all right. Anyway, number 2. Here we go. 3 pieces. Again, get your pencils. Let's graph these 3 pieces. All right. This first piece, it's a line, right? What's the y-intercept of this line? Again, grab your pencils here. 3. And our slope is 1, so go up 1, right 1, 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 down 1, left 1, down 1, left 1. Connect the dots lightly. Okay. Connect the dots lightly. Okay. Next one we're supposed to graph is 3. What's the graph of 3 again? It's a horizontal line through 3, right? This is like the graph. This is like y equals 3 here. Y equals 3. So horizontal line through 3. So right here. Okay. There's a horizontal line through 3. And the last piece is also linear. So what's the y-intercept for this last piece? -1, and the slope is 2. So up 1, or up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And connect the dots. Okay. Erica, Aaron, we're doing a graph here. Erica, Aaron. Huh? I said names together. Erica, Aaron. Erica, Ron. Erica, Ray. Aronica. What's that?
Which comment was that one then?
Maybe. We're not done yet, folks. Hang on just yet. We got time still. Look at that. Look at that clock's up there, okay? I promise you. We'll stop here in a second, all right? Shh. Let's get it shaded in, okay? So we're going to have borderlines where? Where do our functions switch over? At what x values here? 0 is one of them, so I'll draw a dotted line through 0. Okay, and where else do they switch? At 2. So we also need a vertical line at 2 there. Okay? All right, so for the left part here, to the part that's to the left of 0, which one of these 3 is supposed to be to the left of 0? Top, middle, or bottom? The top one is, right? It's for x values less than 0. So for x plus 3, which is this line right here, we're going to graph to the left of the 0. So starting at the 0, and we'll go to the left. Okay, just like that. Should we put an open circle or a filled-in circle at the end? We have this inequality symbol. So filled in, filled, that's right. Okay, just like that. Okay. For the next piece, for the middle piece, right, you see the x values are between 0 and 2. So in the middle, between our border lines here, we're going to graph that 3. 3 is between 0 and 2. 3 is between the 0 and 2. So here's our 0 and 2 border line, so that's going to be it right here. Okay. To the left, it's open circle, but it's already filled in with a dot. And then to the right, we'll also have another filled in dot there. Okay. And then the 2x minus 1, which is this line right here, 2x minus 1, we'll graph that to the right of 2, right? X value is greater than 2. So here's 2. To the right of that 2, we're going to shade in this piece right there. Okay. And again, you can erase away your pencil markings. And then there's our piecewise function. Okay? You can leave your markers at your desk. We'll come around and get those at the end of the day. In the meantime, though, have a seat, please, Grayson, until the bell rings. Okay? I'll get your marker. Okay. No, I want you to stay in your seat. Sorry, because if I let you do it, then everyone else is going to want to do it too. Thank you. Okay, thanks. There is no home. You can leave your markers at your seat. We'll come around and get those, okay? Here you go. Thank you. Yeah, you're welcome.
Easy rookie mistake.
There will be no homework, but please do have a seat until the bell rings, okay?